You may not know that a lot of the technology that's in the smartphone has its roots in DARPA. So Herb mentioned the internet, GPS, the touch screen that's on your phone that enables you to interact with it. That was a DARPA development. The accelerometer that's in the phone that enables you to change the orientation of the screen as you rotate the phone. Siri, okay? Now, what I'm going to show you today is not the smartphone.
We can hack not just computers, we can hack human beings and other organisms. Organisms, whether viruses or bananas or humans, they are really just biochemical algorithms. And we are learning how to decipher these algorithms. When the infotech revolution merges with the biotech revolution, what you get is the ability to hack human beings. Now, what do you need in order to hack a human being? You need two things. You need a lot of computing power, and you need a lot of data, especially biometric data. Not data about what I buy or where I go, but data about what is happening inside my body and inside my brain. And maybe the most important invention for the merger of infotech and biotech is the biometric sensor that translates biochemical processes in the body and the brain into electronic signals that a computer can store and analyze.
What is DARPA? DARPA is the high-tech research branch of the Pentagon. And I'm currently the office director in the Biological Technologies Office. And like many of my other colleagues that are at DARPA, my journey to the agency was an opportunity to expand the impact of the work that I was doing in neurotechnology, find new avenues that it could be applied. So to a person like me, the brain is not a black box. The brain's not just this goop in between your ears. It's a very intricate and elegant signaling of all of these neurons. And what we've done at DARPA is develop the technology in order to sense these signals in real time, or even write signals into the brain.
Elon Musk wants to download your brain with an idea to implant our brains with computer chips. For some people, it's a sci-fi step too far.
And we can effectively achieve a sort of symbiosis with artificial intelligence before the end of next year. And then the interface to the chip is wireless. So you have no wires poking out of your head. It's basically Bluetooth to your phone.
Action potentials produce an electric field that spreads from the neuron and can be detected by placing electrodes nearby, allowing recording of the information represented by a neuron.
Today, data is the most important asset in the world. Those who control the data control the future not just of humanity, but the future of life itself. And once you have enough such biometric information and enough computing power, you can create algorithms that know me better than I know myself. You will not be able to hide from Amazon and Alibaba and the secret police.
How do we do all of this? So this may be your first time hearing about a direct neural interface. And in the middle of the screen up there is actually an example of one of the types of neural interfaces that we're using in humans today. So this is a sensor array. It's about 4 by 4 millimeters. And on this sensor array, there are 96 sensors. Each one of the tips on that little array can detect between 1 and 3 neurons in your brain. All right, and we have the technology in order to identify those neurons, amplify their activity. There's minuscule signals actually happening in your brain. We can send those signals into a computer, and that computer can interpret what all of those signals actually mean when you're thinking about trying to do something. And we can place these sensors anywhere in your brain or even in your peripheral nervous system. We know that these technologies are extremely powerful, and we also know that they can be used for good or for ill.